today we want to look at root functions. I'm going to define what a root function is and then look at the graphs. And so here you can see that the root function is defined as f of x equals x to the 1 over n power, here n being an integer and n is greater than 0. So in other words, x to a power, and that power is 1 over some integer. Okay, so it's some sort of fraction exponent here. Alright, now I have graphs of the first 6. The first one not being very interesting because that's f of x equals x to the first power, n being 1. And we understand that looks like a line. But after that, they get a little bit interesting. So here, notice on the bottom here, we have our evens. And so the first one would be f of x equals x to the 1/2 power. And if you remember, that's the same thing as the square root of x. And the graph of that looks like a sideways parabola, but only half of a sideways parabola. Right? So that's what we get for square root of x. X to the 1/3, you have that same shape in the first quadrant, but we also have some sort of reflection of that down in the third quadrant. Okay, and so in general, the odd roots are going to look like that. You're going to have some sort of square root shape coming from both directions, where the evens, like the 1/2, the 1/4, the 1/6, for example, they're all going to just be in that first quadrant. The reason being is because remember, for a domain, I can't take the square root, for example, I can't take the square root of -4, right? So nothing out here will give me a function value. And the same is true with these. There's nothing over here that will actually give me a proper value. Nothing is the fourth root of -3. Okay, now, if you remember, we had our function translation formula, which says g of x equals a f of x minus h plus k. Then we know something about the graph of g of x. The a either condenses or broadens my graph or flips it upside down if a is 0, if a is negative. The h gives me a horizontal shift, h units to the right, and the k is a vertical shift. Okay, so we can look at an example of this. I already know a lot of graphs now just based off this picture and that transformation formula. Let me show you. Okay, so here's my example. I have two functions I want to graph. The first one being g of x is the negative square root of x minus 4 plus 2. That sounds confusing. Okay, so we'll call it a part. And let me put down an axis. Alright, so first of all, what I'm going to do is I'm going to compare this to something that I know. I'm going to look at the square root of x. The square root of x looks something like that. Okay, now I'm going to apply my transformation. Remember, a here being the -1, flips it upside down, right? So my graph's going to look something like this. Okay, the -4 is a horizontal shift. Since h here would be +4, that would be a shift of +4 units. 4 units to the right. The +2 gives me a vertical shift of 2 units. So I start right there as my new origin, and my graph looks something like this. Okay, now I'm going to erase the blue just so we get a good picture. And that's what it looks like. Alright, now for part B, we do the same thing. Okay, so what function am I comparing this to? I'll probably compare it to f of x equals x to the 1/3 power. If you remember, it looks like a square root going in both directions, so something like this. Okay, now what are these other values? So here a is 1, so that means I don't have any sort of change in the way it's condensed or broadened or flipped upside down. But here h is +1 and my k is also +1. So that means I have a shift 1 unit right and 1 unit up. So there's my new origin. So now my graph just looks like that same picture, just starting in a new place. Okay, so I'm going to erase the blue, something like that. So once you know the basic shapes of these different root functions, and you know the function translation formula, these graphs are really simple. I'd be glad to help. If you have any questions, please don't hesitate to ask me, and thanks for watching.